At the surface of a freshwater lake, the pressure is 105 kilopascals. What is the pressure increase going 35 meters below the surface? So let's start off depicting the surface of the lake and a couple of points. Now they give us the pressure at the surface of the lake, so this will be our reference point. I'll label this reference point, point 1. And at this reference point, we know the pressure and we know the height. So I will say the pressure at point 1 is 105 kilopascals. The height at point 1, being the surface of our lake, is at 0 meters. We then end up going 35 meters below the surface. I will label this point, point 2. So point 2 will have its own pressure, P2, and its own height, Y2. So the pressure at point 2 is P2. We don't know its value. But we do know the height, or in this case, I've been saying height. I should be saying depth. We do know the depth is 35 meters. So this is 35 meters below our reference point. So our reference point is point 1, and we're going to compare the pressure at point 2 to the pressure at point 1. And we know how to do that because the pressure at one point is relative to a pressure at another point, plus the density of the incompressible fluid that we're in, times the free fall acceleration of gravity, times the difference in depths between those 2 points. Now for these static pressure problems, we should indicate the direction of the positive y-axis to be the depth. So as depth increases, the value of y increases as well. So our goal is to find the pressure increase. So that's the pressure change 35 meters below the surface. So the pressure change is pressure at point 2 minus pressure at point 1 is equal to the density, in this case being a lake, it's the density of fresh water times the free fall acceleration of gravity times y2, because I'm recognizing that our depth at point 1 is at 0 meters. So the pressure increase is equal to the density times free fall acceleration times our depth at point 2. Now remember, the density of fresh water is 1,000 kilograms per meter cubed. Free fall acceleration of gravity is 9.80 meters per second squared. So using these values, I know that the pressure increase is going to be 1,000 kilograms per meter cubed times 9.80 meters per second squared times 35 meters. Entering this in my calculator gives me 3.43 times 10 to the 5th kilogram meter squared over meter cubed second squared. Okay, so let's recognize something here. Let's see, I know a kilogram meter per second squared is a Newton, And so what do I have here? I have a kilogram, I have a meter in the numerator, I'm left with a meter cubed in the denominator. So when I'm looking at my units, this is a Newton per meter squared. Remember, a Newton per meter square is a Pascal. So we could say that our answer is 3.43 times 10 to the 5th pascals. This is the pressure increase at 35 meters below the surface of this freshwater lake.